CBSE Mathematics Class 12, Exercise 5.1, question number 32. So that the function defined by fx is equal to modulus cos x is a continuous function. Means fx is equal to modulus cos x. The given function is fx is equal to modulus cos x. This function f is defined for every real number, and function can be written as the composition of two functions as f is equal to g of h, where gx is modulus x and hx is equal to cos x, because GOH means g of h, x is equal to g in bracket hx, that will be equal to g cos x, and finally it will be equal to modulus cos x, and that is fx. It has to be first proved that gx is equal to modulus x and hx is equal to cos x, are continuous function. Gx means the function gx will be equal to modulus x, can be written as, this function can be written as gx will be equal to minus x if x is less than 0. Gx will be equal to x if x is greater than or equal to 0. Clearly, g is defined for real number. Let c be a real number. So case 1, if c is less than 0, ये पहला सिचुएशन लेंगे. If c is less than 0, then gc, function g for c will be equal to minus c. देखिए इधर माइनस एक्स है, इधर माइनस सी हो जाएगा. एंड लिमिट एक्स अप्रोचिंग टू सी, जी एक्स लिमिट एक्स अप्रोचिंग टू माइनस एक्स, that will be equal to minus c. Therefore, the limit gx is equal to gc. Therefore, the g is continuous at all points x, such that x is less than 0. Case 2. If c is greater than 0, then gc means the function g is equal to c, and limit x approaching to c, gx, that will be equal to limit x approaching to c, x, and it will be equal to c. Therefore, the limit x approaching to c, gx is equal to gc. Therefore, function g is continuous at all points x, such that x is greater than 0. Now the third case arises. If c is equal to 0, then g for c will be equal to g0, that will be equal to 0. Limit x approaching to negative 0 means left hand limit, gx is equal to limit x approaching to negative 0 minus x. Third case में minus x, that will equal to 0. Limit x approaching to positive 0, gx is equal to limit x approaching to positive 0, x, that is equal to g0. Therefore, the g function is continuous at x is equal to 0. From the above three observations, it can be concluded that g is a continuous at all points. hx is equal to cos x. अब दूसरा जो हमने फंक्शन एज्यूम किया है, that is hx is equal to cos x, it is evident that hx is equal to cos x is defined for every real number. Let c be a real number. Put x is equal to c plus h. If x approaching to c, then h approaching to 0. Therefore, the hc will be equal to cos of c. Now the limit x approaching to c, hx, that will be equal to limit x approaching to c cos of x. That is equal to limit h approaching to 0 cos c plus h. अब हम यहाँ पर a plus b cos a plus b का फार्मूला लागू करेंगे. Limit h approaching to 0 cos of c cos of h minus sin of c sin of h. Now this limit will be attached to the both part. That is limit h approaching to 0 cos of c cos of h minus limit h approaching to 0 sin of c sin of h. So here देखिए cos of h 0 हो जाएगा. देखो cos of c cos of 0 minus sin of c sin of 0. अब cos of 0 is equal to 1, sin of 0 is equal to 0. So cos of c into 1 minus sin of c into 0. We will get ultimately cos of c. Therefore the limit x approaching to c, hx is equal to hc. Therefore hx is equal to cos x is a continuous function. It is known that for real valued functions g and h such that g of h is defined at c if g is continuous at c and f is continuous at gc, then f of g is continuous at c. Therefore, fx is equal to g of h x will be equal to g in bracket hx, that will be equal to g cos of x, and that will be equal to modulus cos x is a continuous function. That's all.